Hello and welcome to M46, which is looking at now air pollution. So we're looking at major air pollutants and their sources.
Air pollution consists of chemicals or particles in the atmosphere that pose serious health and environmental threats. But what causes air pollution and what does it mean for our planet? Some air pollution comes from natural sources like volcanic eruptions, wildfires, or allergens. But most air pollution results from human activities such as energy use and agriculture. There are different types of human-made air pollution. When we burn fossil fuels to produce energy, they release greenhouse gases into the air. These emissions, such as carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap heat from the sun in Earth's atmosphere, leading to a rise in global temperatures. This creates a cycle where air pollution contributes to climate change, and climate change creates higher temperatures. In turn, higher temperatures intensify some types of air pollution. For example, climate change increases smog because it forms in the presence of high heat and increased levels of ultraviolet radiation. More frequent extreme weather, such as flooding, contributes to damp conditions and therefore to a rise in mold. Warmer weather also leads to longer pollen seasons and therefore more pollen production. Smog is a type of air pollution that reduces visibility and has serious health effects. Smog can be divided into two categories: sulfurous and photochemical. Sulfurous smog is made up of chemical compounds called sulfur oxides. It occurs when burning sulfur-bearing fossil fuels such as coal. Photochemical smog, also called ground-level ozone, is a result of the reaction between sunlight, nitrogen oxides, and volatile organic compounds. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. Volatile organic compounds are released from gasoline, paints, and many cleaning solvents. Smog not only creates a brown haze that reduces visibility, but also harms plants, irritates the eyes, and causes respiratory distress. Another category of air pollution is toxic pollutants. These are chemicals such as mercury, lead, dioxins, and benzene that are released during gas or coal combustion, waste incineration, or burning of gasoline. In addition to adverse environmental effects, toxic air pollution can cause serious health problems such as cancer, reproductive complications, and birth defects. While air pollution has many consequences for our planet, there are solutions. We can limit toxic pollutants, smog, and greenhouse gases by decreasing the use of fossil fuels, such as in transportation, manufacturing, and electricity generation. Reducing air pollution not only contributes to a cleaner environment and better human health, but can also slow the rate of global warming.
All right, so we'll talk about those different types of smog. The first one is, basically, they're caused by primary pollutants. So primary pollutants are things that directly cause smog. So VOx, so we call them VOx, but they're volatile organic chemicals. And those are just evaporation of gas and solvents. So like I mentioned before, any kind of smell, like paint smell, new car smell, new things smell, those are all volatile organic chemicals. And so they aren't necessarily good to smell those kind of things, but those are pollutants. So those are, we refer to them as VOx. And then carbon monoxide. So that's from incomplete combustion. So if we don't have something completely combusting, some kind of type of gas like natural gas or propane, or an automobile gas, then we can get carbon monoxide, which is very poisonous. NOx, so that could be NO or NO2, and that's from all combustion. So anything that burns would be producing NOx. And then SO2, sulfur dioxide, would be combustion of fossil fuels, including sulfur. And then particulate matter, so particulates in the atmosphere, what you guys are measuring with your petri dishes. That's just from combustion of fossil fuels, biomass. It could be dust, dirt, pollen, any of those things. And then lead gets into the atmosphere by oil and gasoline. All of these form from burning fossil fuels. Sometimes it's organic, like volcanic eruptions can produce sulfur dioxide. And forest fires, of course, can produce carbon monoxide into the atmosphere as well. No table 46.1, so that's on page 541, and that just goes over these different things. So definitely make sure you know these. And then also on FRQs, make sure you guys are saying specific things. So if you say pollutants, that will get you nowhere. So you have to specifically list what pollutants. So if you're mentioning pollutants, mention VOx or NOx or SO2 or carbon dioxide or something like that. So mention something specific. Don't mention a general thing. So pollution is one. Greenhouse gases is one. So those are two general of terms. So make sure you're listing stuff that's very specific. All right. Clean Air Act. So the Clean Air Act of 1970 set out to reduce sulfur dioxide, nitrous oxides, carbon monoxide, particulates, lead, and ozone. It didn't say anything about carbon dioxide. And that's just mainly because we didn't know a lot about it and we didn't tie carbon dioxide into global warming. And so in 2012, it was modified to include carbon dioxide. All right, secondary pollutants. So what this means is they're not directly contributing to smog or atmospheric conditions, but they are mixing with something else to produce something that's a pollutant. So they're not directly affecting something, but they're combining with something else to cause smog or pollution. And so they can undergo changes because of sunlight, water, carbon dioxide, oxygen, or other things. So some things that produce other things, NOx, so nitrous oxide, nitrous dioxide, produces HNO3 and ozone. And so that on the ground is not a good thing. So ozone in the atmosphere, great. It helps to block out harmful radiation. But ozone on the ground, O3, is smog. So that's generally what photochemical smog is. And then sulfur dioxide produces H2SO2, which can then combine to make acid rain. So these things directly, NOx and SOx, directly are not involved in acid rain, but they mix with other things in the atmosphere to produce acid rain. And acid rain, of course, like we talked about, can devastate forests, aquatic life, so amphibians and things that are very sensitive with their eggs to different amounts of acid, and so that can definitely affect their reproduction. And then in order to produce smog, it's O3, so I included the equation down here, but O3 plus NOx, so remember that could be nitrous oxide or nitrous dioxide, and VOx, so volatile organic chemicals, plus temperature inversion, which we'll talk about in a minute, and that is due to sunlight, and that produces smog. So that is what we refer to as smog. Prevention is just to reduce VOx and NOx. So try to remember those catchphrases because those will help you a lot. This is definitely going to be on the test. So make sure they definitely, with everything going on in the world, they really definitely hit up pollution, smog, climate change quite a bit. All right, so here's temperature inversion. So what happens is that the picture on the top is normal. So those are normal conditions. The ground warms faster than the air, and the air rises. So it's warm down here on the bottom, and that warm air rises, and it gets colder as you get farther up. So that warm air is able to escape. And notice how this combustion, the NOx and SOx and things coming out of these factories are able to rise with that air. So a temperature inversion is the bottom picture. So temperature inversion is where you have colder air on the bottom. So the ground cooled off faster. You had maybe a warm front moving in. And so what happens is warm air is already on top, cold air is on the bottom. So warm air rises. But if warm air is already on top, then the cold air is just going to kind of sit there. And so we get this cold air sitting there, and that pollution just sits there and doesn't move. And this is what created the Great London Fog. So they call it London Fog, but it was actually a tremendous amount of smog. In the 1950s, it killed up to 8,000 people. Pretty insane amount of smog. But anyways, so that is caused by temperature inversion and obviously an excess amount of combustion. So sometimes think about like in the area, sometimes you see in Reading, it'll be a cold day and the skies are clear and it doesn't smell bad. And then some days it's cold and you smell all the wood burning stoves and everything around. And it's not because people are burning more wood that day. It's because there's probably a temperature inversion. Same thing in the summertime. So sometimes you go down to Sacramento and the skies will be clear and you can see the buildings right away. And then other times you go down to Sacramento and you can't even really see the buildings until you get really close to the city. And that's probably because there's a temperature inversion. It doesn't mean that they're making more pollutants one day versus the other. It's just that the air is not rising fully. All right, so photochemical smog. This is brown smog. So this is typical of LA. LA has this. So it's formed when NOx, so nitrous oxide or nitrous dioxide, which is from burning fossil fuels, plus sunlight, plus temperature inversion. So this is often happening in the summer when we have hotter temperatures, and so it's just warmer on the. It's warmer up here, colder down here because it cools off at night, but the air temperature stays warmer up top, so it causes the air just to kind of settle. So that's called brown smog. And then we've got sulfurous smog. So this is what was the Great London Fog in the 1950s. And so it's smoke plus fog. So burning things, burning wood, coal, plus fog produces this industrial fog. And so it's often called London fog because it was a pretty devastating fog that happened in the 1950s. All right, air pollution sources. So different things that produce air pollution. We've got factories, transportation, natural fires, VOx. So I listed on the bottom some variety of things that produce VOx. So building materials, home personal products, fuels, machinery, basically anything that you smell is producing VOx. And then volcanoes. So volcanic eruptions can produce a lot of sulfur into the atmosphere. All right, so health effects. We've got lung disease, heart disease, cancer. You can see this is some pretty tremendous pollution. So it's pretty bad. It looks like fog, but it is actually pollution. So it's found where there's high industrialization. So these areas that you see in these pictures, high industrialization, low regulation. So they are not regulating the amount of pollution into the atmosphere, and it's pretty obvious. A lot of these pictures are from India. So it's very, very obvious that there's not a lot of regulation because that's pretty significant when you can't even see across the street. All right, and that is it for these, and I will see you next time.